Okay, so the next one here is just going to be a quick example for putting our methods into a separate module. That way we don't have to worry about that order issue that shows up with interpreted languages. Just a hello world will work here, but for the planning, trying different things, going back and forth, seeing what different types of plans work best, I'll just do the whole plan in a UML diagram, a UML use case diagram. We have our user, and somewhere over here we're going to have the parts to our plan. Well, we're going to create that module, create our methods in a separate module and then import them. So we're going to put that over in storage. I'll just call it hello. Then at some point, we'll need to import that. So we're going to go out there, grab it, bring all those methods in, and that way we don't have to worry about that. For this simple example, just looking at the syntax, there's only going to be one there, but I'm going to put a start block here. Kind of connect these with arrows. Then have a print that's going to access the method we pulled from there. Then an end. So our use case, coming from the user, we'll hit the start point, kind of flow into that input. From there it goes down to our print statement, which makes use of that, and then outputs it back to the user. The basic idea, the key point here is going to be the syntax for putting our methods into a separate module. That way we're not restricted by the order we type them up in. Okay, so this example should go really quickly. Come over here, we'll start up idle. There's not a whole lot to this one. This is just about putting it in different modules. The standard workaround to deal with that, to get around that thing of having to type the methods in a certain order. You don't want to worry about the order, and you know what methods you need. You just put them in their own module. So I'm going to come over here in the first file. I'm just going to create a function, just a basic one here. This example is going to go quick. I'm going to bypass the weekly notation, and we'll do that in the big example that covers everything here in a moment. Just a simple hello world in this case. That's probably enough. And then that first example didn't have void methods. So when we're done with the method, just undo the indenting. Method finished here. And then when we save it, so Control S to save it, it'll navigate to someplace to save it. I'm going to put it on the flash drive with the videos. What can I call this? I'll just call this hello. Hello.py. And that hello.py has this function called say hi. Then if we come over here and create a new one, another new file, here's where I'll put the actual code. So like we've seen many times, import hello. So this is going to go out to storage, look through all the stuff in storage, see if we can find a hello.py file. And it's going to find this and bring back all the information in it. So all of the setting up the methods runs in that one line here. And I'm going to comment it out here, but this is a really good one to use, that from hello import say hi. This would be a really good one to use this method, the from notation. Then that way we don't have to put hello dot. I don't have to put the module dot, but I'll just do it this way. That's fine. Then I'll put out a print statement. Oh, I don't know, maybe a couple of statements. Getting ready, print, and then we can do hello dot say hi. That way there's a couple things in here. And then that's going to look at that other module and import that method. So if we hit Control S, save that over here on the flash drive in this folder. Notice right now, the only thing in there is these two modules. I want to open it up here. Open up regular File Explorer. Go to the flash drive, and in here, in this folder, we'll see, oh yeah, I've included a PDF of the date codes from that first example. I just went and found one really quick. A quick Google search, copied and pasted them in there. But you'll see that only the two .py files in there. So I'll save this as, I don't know, test.py. Test hello, that's probably a better name. So test hello.py, testing all this stuff. So now when we push F5 to run this, you can see it called that print method, which is in a different file altogether. Did I close that? I didn't mean to close that. But that's how we can get around that, having to worry about the order we create our methods in an interpreted language. Just put them in another file and call that up. And the last thing, notice that when I ran it, it created this folder PyCache, which has some internal stuff going on. You can see the file type is compiled Python file. So it automatically transferred that to a compiled version, a compiled file, to import all at once and read. So it has that other thing in there once you run it. And that's about all for this example. Just a quick overview of that. Hopefully that made sense. I meant to put those in another folder. So yeah, just either go ahead and install that where the rest of your Python files are, or put it in the same folder as your actual program. At this point, we haven't got to the installing yet, so obviously at this point, just make sure that that is in the same folder if you want to do it that way. Either method is fine for the homework, whichever way you prefer. That's going to come down to personal style. Just remember, if you put it all in the same file, we have to worry about the order. We're going to see that in the last example. And if you don't want to worry about the order, you put the methods in, define the methods, just put it in a separate file and make sure they're in the same folder. For our last example here, well, yeah, there's not really much wrap up on that last one. That was just a quick example on that workaround for the limitation that interpreted languages put on us. Our last example here, I want to kind of cover everything. Most everything we've seen so far was return methods. So we want to have something that includes void methods and kind of mixes them together. Something a little bit bigger. So I was just going to do a sales tax thing, sales tax calculator. Should be fairly straightforward. I feel it's safe to assume everybody has been to a store and bought something, so you have kind of an idea of how sales tax works, the different parts to it. And one of the homework assignments this week is to go back to Module 2 and take one of your programs from that and clean it up with modules, put it into modularize it, which means take all that code and put it in methods. So I know one group of the homework assignments had a sales tax thing on there. So if that's on yours and you want to clean it up, I guess just do it different than what I do for the example, which shouldn't be any problem because I keep making that point that we all think differently. So there's surely going to, if that's one of yours, there's surely going to be something as I go through this that you're going to think, oh, there's got to be a better way to do it, or this other thing would be a better way to do it. So just do it your way. Just try not to do the exact same thing I did here for if that's one of the assignments for you to clean up this week. So the first example, I tried to do a detailed plan, a very brief one. A couple of you guys that did decades in the Army probably have a much more refined definition of what a detailed plan is than that one I threw up on the board, but hopefully the general point got across there. So for this last one, let's go the other end. Let's make a complete mess of the plan. And, just experiment around, see what works best for you. So what are we going to need for a sales tax calculator? Well, obviously we're going to need an apply tax method. Apply tax method. I'll do that for a method that just takes in price. Might as well put that here. You can take in a price and then tax times price gives us a sales tax on it. What else do we need? I guess we'll need to get the price method. Get price. Some sort of method from that. We don't need to pass in any arguments in this, or we don't need to accept any parameters because that's going to come from the user, right? Ask user for price. And I'll do this. Kind of really accentuating the make a mess of it to, figure out what works best for you. So we got a price, apply the sales tax. Oh, some constants for sales tax. That, it's usually good form. Instead of writing, we're in Indiana, so instead of writing 0.07 every time we're going to need that, let's just put it to a word at the beginning. That's going to be an assignment. Sales tax. Constant. We'll figure out a name for it. Well, might as well do state and local. It's not that too difficult. A state one, a local one. Sales tax, constant. I ran out of room there. Just jotting the ideas down, getting things ready, getting the blood flowing to the brain, thinking about what all the parts we need. What else will we need here? So we apply the sales tax, get the price of the item, the value of the sales tax. Might as well do an output method somewhere. Probably not going to go with that name, but some sort of output method in there. Might need that. And we haven't seen it yet, so let's do a main method this time. Main method. Well, that's different notation that I've been using. Some sort of main method, which just calls the other methods. Calls other methods. So really accentuating that it can be a mess here. Whatever it takes to, whatever helps to get the ideas going. I guess the last step for a plan, so this is probably all the pieces we need. And does it cover everything? So let's see. That's going to be a return method that doesn't take any parameters. Here's a return method that does take a parameter. Our main method doesn't take any parameters, and it's going to call a bunch of methods. So that's what's going to start everything. So it's going to be a void. There's no place to return for the main. Our output will also be a void. Oh, a void that takes in a parameter. So void total. We'll pass in total. The total is a parameter to the output. So then we have void methods, one without parameters, one with. Return methods, one with a parameter, one without. A couple constants in there. So that'll be the first thing we do. I guess the last part of our plan is what order do we need to do these things in now that we have the pieces. First thing is we want to set up our constants. You can do that right at the top. That way they're easy to get if a state Congress changes the sales tax, it's easy to adjust it for the program. The main method is going to call all the other ones. So I was just going to do this in one file again, not do that thing we just looked at a moment ago. So that means that's going to need to go last, because we're in an interpreted language, so all the other methods need to be written before the main. The other ones I don't think are going to depend on each other, so we can just put an order to those. We'll do this one second, apply the sales tax, then do a third one, getting the price from the user, and then we'll do the output fourth. So just really accentuating that point and countering that one earlier with the detailed plan of it can be a mess. If that's what works best for your mind, do it that way. Whatever works best for you. So let's go try putting this together real quick, and then we'll come back and do a wrap up on the examples. Hopefully I covered the syntax thoroughly enough that you can just run with it and build from there. All right, so let's get working on this example. This is a slightly bigger one. Probably might want to call this the actual example for the week. It goes over everything. Those first two were small points, just the general syntax, and then that workaround for the order. Starting up idle here. And creating a new file. That way we have a text file we can edit instead of typing them all in one at a time. Which I don't think we've shown. Might as well show that at least once. You can type those in here. If, I don't know, 3 is more than 2, print. Right, let me switch that around and go into an else block to kind of demonstrate this. Print less than else print more than. You can see we can type that over multiple lines. It's still the indenting. That going back looks a little bit different, so you kind of have to visualize that those are on the same level. And when we run this, we get the else statement. So we can type the whole thing in there. We hadn't actually seen that, but well, if we need to do that again, we can either have to type it again or copy and paste. So that's why we usually go to the text editor and just type the file in here. So to start with, a note about our notation. I made a comment in an earlier video. I'll keep referring to these as multi-line comments. I guess it's important to distinguish this isn't necessarily a multi-line comment, as we have in some languages. A comment, the computer will just ignore. This is a string. This is precisely a string, but we're not putting it anywhere, so it's not going to be used again or anything. So garbage collection will immediately grab this and clear it out of memory. So it kind of effectively, it's like a comment, but it's not being ignored. So if you have a lot of stuff in these type of strings, it might, or a lot of these type of comments around, it might start to slow things down. Just a slight technicality there that I thought I should probably mention. So our weekly notation is going to be camel case, at least 3 words long. Just to practice this, and camel case is probably the most popular notation you'll see amongst programmers. And it's not a standard laid down anywhere. There is a convention that most programmers follow for object-oriented programming, and camel case is part of that convention. So that's one of the reasons it's so popular. I guess there are different reasons. It just comes down to preference. It's kind of the one I prefer to use. So, like we saw in the plan, the first thing is a couple constants to store the tax rates. Tax rate, I'll go ahead and do 2. State tax, I'll just call that 5%, and the local tax, trying to make sure there's something 3 words long, written in camel case. Adding the word the just seemed like a good spot. I'll do 2%. I don't know the exact values in Indiana, but I know it's 7% overall in Indiana, so I'll just kind of go with that. And then having that stored in a variable, it makes it a lot easier to change, right? We can just go in there and change it in that one spot instead of typing 0.05 every place we need it. You'll often hear that referred to, if we type 0.05 everywhere, you'll hear that referred to as magic numbers, because if somebody else is reading through your code, that kind of looks like a magic number. There's no description on it. It just shows up, does its thing, and then disappears. So it's better form to store things like that in constants. It also makes it a lot easier to change, because then if we need to update the tax rate, we don't have to change it in one spot. So I'm going to do that thing that y'all have seen me do a few times, where I kind of jump out of order, right? I'm going to come down a few lines, and down here, the first function I'm going to define will be the main. So somewhere down here, we're going to need this thing, price of items. The things we're going to do. We're going to know we're going to do that. And this is kind of the order I go in. I jump around and go back and forth as things are needed. So that's going to equal a function that hasn't been written yet. We're going to get that from a function called ring up items. I guess the standard note for that. And I wanted to do this. We have the whole plan. We could just type it in order. I wanted to do it this way because what I often do is when it's starting to come together like this, I'll just kind of start putting things together. I need a method. So at that point, I'll just come back up here somewhere and put that method in. So define a function, ring up items. And for now, I'll put a placeholder in there. Function coming soon. And when I'm building up things, programs, I often start with something like that and just kind of put a placeholder there. And as it gets more advanced, I'll come back and fill in that placeholder. And that's just for how I work in the details for the plan. We don't necessarily need to do that here. In our case, we can just go ahead and put that in. But that's sort of a placeholder, and build up the methods that way and then come back and fill them in later. That's just what I've worked on over the years. So I'm going to improve this in a minute, but to start with, just going to grab input from the user. So input, please enter the price of the items. Well, I'll put item, just one of them. So the user is going to give us a number, which should be a price. So that's a floating point number. So like we've seen before, we need to cast that into a floating point number, cast that. And we don't necessarily have to assign it anywhere here because we're going to return that value. And when we return it, it jumps down here and puts it in our variable in the main. So we don't need some global thing to carry around. I guess there's not really a global. These are global, so we're going to access these but we often want to minimize how many global terms we have. Minimize the global variables and try to keep things local as much as possible. So that's things like this. Passing the values back and forth in the background, let the computer handle that because the computer will never get confused on them. And then we only put them into named places where we're going to work with them. So the next thing, I'll go ahead and write it as a method. I just wanted to start that off and show how I tend to jump around and put in placeholders and work in sections. I guess the next one, I want to write this first because this is going to look a little bit different. Apply tax rates. And in this case, well, you all should know how taxes work, right? We take the price of the item, multiply it by the tax rate, and then that number adds to the thing. So we want to do that. But I set up two here, a state tax and a local tax, which kind of go together to give just one tax rate. But really, they are separate things. So I'd like to return both dollar amounts on those separately. That's why I wanted to set this up as its own thing. That's why I wanted to do this, type up the method before assigning it, and show how to handle multiple returns. So obviously, in this case, we're going to need a parameter, though, because we're going to need the price of the items, and that's down here in the main. So when we set up our method, we just need a place for something to be passed in. What's a good name for that? Thing being taxed. Fits our criteria. 3 words written in camel case. Thing being taxed. And kind of describes it. Well, then we just talk about the thing. So what are some names? State, sales tax, the actual dollar amount. Well, that's going to be the thing being taxed times the state tax. And almost an identical one. So local sales tax, yeah. Again, it's going to be the thing being taxed times the local tax rate, which is stored as a constant for our program. Normally, we would use camel case and all caps case to signify which ones are constants and which ones are variables. But one of the points this week is each week in this class is going to be studying the different notations. So here we're just using camel case for everything. So now we have 2 values, and we'd like to return both of them. So some languages don't allow that. Some programming languages only allow us to return one thing. And in that case, we'd have to, if we had multiple things, we'd have to build up an array, return that array, and then parse it back out, pull the items out of the array on the other side. But Python does allow for multiple returns. So we can throw in our return statement and then just give a comma-separated list of the things we want to return. Or comma-delimited list is the technical term. So state sales tax, that's the dollars. So I'm going to add dollars on the end of that just to help specify what it is. State sales tax dollars, then a comma, because we're going to delimit this list with commas, then return local sales tax dollars. So that'll return both things. And if we're returning two things, then when we go and ask for them, we need two places to put it. And again, it will be a comma delimited list. So back down here in the main, after we get the price of the items, we're going to put those into these variables to hold them. So state tax addition kind of describes what that is, right? The amount of money added on from the state tax, comma, local tax addition. And the order has to match. So whatever order they're being returned in is the order it will be put in here. So we can do multiple assignments with Python. That can be incredibly useful at times. And we're going to get those values from that method we just wrote. Apply tax, what do I call it? Apply tax rates. And it's expecting a parameter, and the parameter is the thing being taxed, so that's this price of items. So that'll get our price, then get the sales tax from different methods. You can see how it's organized nicely when we set it up with methods. Now, one thing real quick before we get too far away from this method we just wrote. I'd made a point in the lecture to talk about this. We have these global values, these global variables, holding values that we're going to use in this method. And this would be okay here. We can access them. We can get the value from it. What we can't do is we can't change those from inside a method unless we add in a keyword. And I think I mentioned in the lecture, I like to always go ahead and add in that keyword, and it doesn't show up anywhere else in the example, so I'll go ahead and throw it in here. This isn't necessary in this point because we can access them. But personally, I just go ahead and always throw in the global keyword to explicitly state we're working with the state tax, and the local tax. If we want to change those from inside a method, we have to include the keyword. But we can access them. So with this program, we don't necessarily need that line, but my own personal style, I just go ahead and include it every time just in case it's needed later in an update, or that way I don't have to stop and think about whether I need it or not. I just go ahead and put it in there. So just the keyword global gives you access to change them. But maybe part of the reason I like to include it is that if I come back to do something with this code 6 or 9 months from now, 2 years from now or something, it's a handy little reminder that those are global variables, not local ones. Whereas this one is created inside this method and is only used inside this method, assigned a value, and then used in the return. So it is local to this method. We can't access it from anywhere outside of that method, being the difference between global and local. Okay, so now back down to our main. So now we have the price of our items, how much the state tax is going to be, and how much the local tax is going to be. So we're ready to total everything up, right? Total price today, again, 3 words in camel case. There's lowercase letter on the first word, capital letters on each subsequent word. So the total price today is just going to be the sum of all of those. Price of items plus the state tax addition plus the local tax addition. And I guess now we're ready for a display method, right? Then we can call this method display sales total. Sale total. We usually do that as just singular. Either way, it won't really matter. And here, obviously, we're going to want to pass in that value that we just calculated in order to be displayed. Or if you wanted, you could do this calculation right here and pass the calculation in as an argument, because then the computer would find that value and pass the value. Well, we already saved it somewhere, so I'll just use that. Total price today. And we'll need to write this method. So I kind of jumped out of that thing I was mentioned at first to go over that multiple returns. The big thing there is the order matters. So whatever order you return them in, make sure you assign them in that order down wherever they go back to. Normally, I would just come up here and define the method, display sales, total. So I'd write all this main method stuff, and then I'd come up here, and at each point, I want to call it something different than that. Total sale price. Just to indicate the name. The name doesn't come with it, right? It's the value that name refers to is what's being sent, not the name itself. Kind of explicitly state that. Normally, I would set all that stuff up in the main and then come up here and write something like function coming soon, just as a placeholder on all the methods, and then I come back and fill them out one at a time as I got tested. Because then I could check each run. But here we're ready to fill that out, so we don't necessarily need to do that. This one is going to be a print statement, so we're working on the console. So print the total today is $, and then we're going to format that number. Format that to look like it. So total sale price. Remember, we need the local name. So here's our local name for that value, not the name we assigned down here. So we'll have to pay attention to that as you go back and forth, because the name doesn't go with it. Just the value that that name's holding is all that gets sent. So total sale price, and it's money, so we're going to do 0.2f, which again reads backwards. So that's a floating point number that shows two digits after a decimal. And one more parenthesis to close all that out. Hopefully all that made sense. Let's run it and see if we create any errors, because I was trying to talk and type at the same time. So Control S to save it. And I have a flash drive here somewhere. This is in Module 3 stuff. These lectures. Oh, I'll just call this tax thing. That's a good name. Tax thing.py, and then F5 to run it. Something seems to have gone wrong, didn't it? So let's see what happened. Price of items is going to come from this thing, ring up items. Well, let's put some echoes in. So this is a common thing. Let's put echoes in to see where it started main. Let's see if it got that far. Nope, it didn't even print out that echo. Oh, I see what happened. Down here at the bottom, we defined all these functions, but we haven't actually asked for any of them yet. So we need to call the main function there. Put the scroll thing in there. White space for scrolling. So we can get up here. So after we write everything, we have to actually call that function. Control S to save it, and F5 to run it. Oh, now we got our echo. So that's a common thing you're going to want to do in debugging. So we're past that echo at least. So I'm going to go ahead and delete that. And get that line out of there. I don't need that echo anymore. So please enter the price of an item. Let's start with $5.98. Oh, got an error. Line 40, line 35, and total display total, sales total, sale total is not defined. So I'm not sure which one. Oh, I put an S there, but not there. I started to, then took it away, and then was talking and typing at the same time. I kind of expected some little errors like that to happen, but so I'm going to put the S back in here. Display sales total. Let's try that again. So the price of an item, $5.98. Total today is $6.40. That seemed like it worked. How are we doing on time? Okay, I don't have to render this video down just yet. Got a couple minutes still. Maybe we could expand this, right? People usually buy more than one item at a time. So why don't we come up here to the ring up items and show like an update, like, right? So this thing worked. It's all going good, but no, time to update the software. People are going to buy more than one item. We don't want to just enter the total at the end. Let's enter the items price by price, item by item. So I'm going to comment that out. A good rule of thumb is never delete code immediately. That way you can get back to what works. Comment it out, try new stuff, and then delete it when you know you won't need it anymore. But always keep things around so you can get back to the last thing that worked. So we'll set up a while. We could run through a loop. When we saw while loops, so a while loop will work, just a basic menu-driven thing. We'll just ask the user a yes or no question, like, is there more things? If they say yes, we'll do some more. And then that'll be our condition. So while making up some name here, more items to include is equal to the string yes, well then we'll get a bunch of items. Get a price, ask if more, kind of the idea. Hopefully that part makes sense. So let's fill in the thing beforehand, because we need to have this equal to yes the very first time it hits the loop, which we refer to as priming the loop. So more items to include, and we'll just start that out with a yes. We'll assume there's at least one item, so we want to go through that loop at least one time. And each time through, get a price, add to total, right? We're going to get a price from the user and add it to a total, so we need a running total as well. Current subtotal of sale. It's our naming convention, right? It's at least 3 words written in camel case. That's going to start at 0, 0. And then each time through, well, we can go ahead and write this. And then in the end, after we're done with our while loop, undo the indenting back to the level for the function, and we'll return that running total. Current subtotal of sale. So that's kind of a point I've expressed a few times. I don't go right in order. I jump around and write the code as my mind thinks about it. I find that works a lot better for me. So now through our loop, well, we need to add up that subtotal. So current subtotal of sale. Well, that's going to be this, right? I'm just going to copy it from up here. Control copy. Oh, And it's not just going to be assigned that, it's going to increment by that. So each time through our loop, our subtotal is going to do the increment assignment with whatever price the user gives us. And then we can just throw up the prompt to see if there's more or not. So, more items to include. That will equal some sort of input. Input, are there more items to ring up? Enter yes or no. A very explicit prompt, because we're going to be looking for the word yes. And if it's yes, it's going to keep going. If they enter no, then we'll be done with it. Okay, so let's hit Control S to save it, F5 to run it. Enter the price of an item. Well, let's try that same number again, $5.98. Are there more items? Yes, there are. Well, could probably use a space in there. I'm going to go ahead and type that immediately. Colon, space. That way I know it's there. So I'm going to type in yes. Enter price of another item. Oh, 9.73. 9.73. Another item, yes or no? Yes. The price of the item, I don't know, a pack of gum, 0.35. I think that's what packs of gum are still running. That seems to work. Let's type in no, see if that finishes it out. The total today is 17.18. Yeah, that seems about right. One thing you always want to do when debugging is check and make sure the numbers are working. So I made that change that I noticed. So I'm running this again. F5, and might need to move this up a little. Let's go and hit the bottom. So enter the price of a number. We want to check things that we can confirm is right. So let's enter, I don't know, 3 items that are $1 each. That'll make for easy math. Another item, yes. It's also $1. Like we're shopping at the Dollar Tree or something. Yes. This is also $1. Nope, that's all. So the total is $3.21, which it should be. 1 plus 2 plus 3. Then our total sales tax comes out to 7%. And 7% of $3 would be 21 cents. So it looks like everything's working there. And notice how on that first pass, everything worked. And it's like an update. How much easier it was to update, because everything was nicely organized into methods. So then when it came time to update the software, we were able to go to just that one method that needed the update and address just that little piece. So using functions or methods, whichever term you prefer to use with whichever one you want to call them, it organizes our code, makes it easier to update and find problems in, because we can jump to the method where the problem happened and deal with it in small sections. It's also very useful when we get to GUIs, because then we'll write the method the software is going to do one time, but then we'll give the user 50 different ways to call up that method. So, you know, the menus up here, the right clicking, the keyboard shortcuts, there's lots and lots of different ones. So we want to include that when we get to the interface, but we don't want to write a whole bunch of different methods. We'll just write the method once and then call it different ways. But a very, very important aspect of software development, because it makes a whole lot of things easier. And hopefully all that made sense. If your homework this week involves updating program from chapter 2 that was essentially this. Just make sure you do it a little bit different, but we all think different, so I feel quite confident that there was at least one thing that I did there that you probably very quickly thought I would have done that differently. So yeah, just make sure yours is a little different than that if that was your assignment for this week. And as normal, I'll get some comments in here and send this out when I post the videos. And let's go back to the board and wrap this up real quick. Okay, so hopefully all that syntax stuff made sense. One of the things about Python is it's easy to work with. That's part of the reason for popularity. That was one of the core concepts when we started making Python to begin with. Was the guy thought there should be a language that's easier to work with. And so a lot of the syntax stuff in Python, hopefully that all made sense. The syntax is easy to work with. Hopefully it all made sense and kind of slid right into place with the other syntax we've seen so far. And yeah, just a quick wrap up here. This is kind of what my plans look like. Whenever I'm making a plan, it's a mess. I keep saying list when I'm talking about it, but it starts like this, and then things over time, things will get scribbled out, and layers, little bits of white space will be filled in, and there's like layers of a mess when I'm making the plan. And then by the time that's what works best for me. You just need to look around and see what works best for you. But I keep saying list, and really it's, by list I mean a mess that somewhere on there says first, second, third, fourth by the end. That's just what works best for me. There's different ways to do it. Experiment around, see what works best with your mind as far as how to plan these things. And making plans at this point should be easy because the programs are small enough to fit in weekly homework assignments. So making a plan for them should be fairly small plans. But I guess that'll wrap up the examples here. I think earlier I said that this week was methods and functions and then arrays and lists. I double checked since then. Next we'll be into files. And then next week on module 4 is the list. So we'll get into reading, writing files, the next thing, and making data persist.